We did a whole bunch of work. What do I need now? I'll switch to black ink. What do I need now? I've drawn the triangle. I got to find angles and sides, don't I? Do I have the information I need to find angles and sides? What is the information I have that I can start with? 20 over sine 58. And now I can just set it up, can't I? So we know this has to be B. We know this has to be C. So go ahead. What's going here? $10. And what's going here? Sine B. Now I got to solve that, don't I? What's weird about solving this? You're finding an angle, so what are you going to need to do at the end of it all? Shift sine. Can you do shift sine at the beginning? You can if you get good with your calculator. If you write down your work, you can do this all in one step on your calculator, but you have to write it down. Because you know that this is 10 sine 58 divided by 20, correct? Now, if you put shift sine in front of that and put that in brackets, you'll get the whole answer in one shot. But that's tricky. Is this calculator 10? Do I give you bonus points for being able to do it all in your calculator in one go? No, of course not. So if you can't do it all in one go, don't feel bad about it. If you got to take 2 steps, take 2 steps. Because this is going to give you a decimal, isn't it? 10 times sine 58 divided by 20. That's going to give you 0.424, isn't it? Is that an answer? No, you got to shift sine that to get what? 25. Right? So now I know B is 25. Do I now automatically know C? Why? Great. So how big is C? Pardon me? 97. So now I can come up to here. I have little c over sine 97. Now, I know B is 25 now, so I can change that to 25. Or I can use the original 58, can't I? Because they're all equal. So how big is C? (10 sine 97 divided by sine 25 will get me C. And what do you get there? 23.5. Yeah? So now, does it work? Do we have smallest side across from smallest angle? Middle side across from middle angle? And largest side across from largest angle? So did we do it right? Yes. It's the nice thing about trig, it's always easy to check. You never have to wonder if you did it right or not, because you can always look. If you did it wrong, can't work. For example, if you hand me in a test that shows the hypotenuse as shorter than one of the other two sides, have you done your trig right? No. Some of you will hand me in a test that does that. I know, because I've marked approximately 50,000 trig tests. All right, so let's look at this next one. You guys have a look at that. What's changed? The angle is different, but is it still fixed? We're locked into a 71, right? I changed the order. Why did I change the order? Because it doesn't matter. Right? We get very tired of hearing, I can't do this math because it's in a different order. It's got different letters. Can't do it. So what am I locked into here? What do I have to draw? I have to draw an angle of 71. Yes? Where should I put the other two? Well, I know that 12 has to be over here somewhere, yes? So can I put 12 on yet? Yes or no? No, because I don't know where that third side's going to be. It might be here, but it might be over here, correct? So I can't do anything with 12 yet, so what does that leave me? Just the 17. Where's the smart spot to put that 17? On the diagonal, right? Because I put it down here, I can't get my altitude, can I? So now, can I get my altitude? Sure I can. There's my h. What do I call that? How do I find that? 17 sine 71 will get me h. So what's my h? 16. Right? Everyone cool? Okay. Now my third side is 12. What's the shortest my third side could be and make a triangle? 16. My third side is what? 12. So this is 16. My third side is 12. Will it ever reach? No. So can this even make a triangle? No. So no triangles possible. Is everybody starting to grasp this? Okay, you guys try the third one because the numbers are gigantic. Does it matter that the numbers are gigantic? No. You guys do this one. Talk to your neighbor if you need to. Just remember, what are you locked into and brand new projector remote still doesn't work. When I was in Hollywood, I nearly bought a remote, a wand remote. Like they have at Great Wolf Lodge and at Hogsmeade at Universal Studios, but you can program the remote, the wand, to do stuff on your TV. So if you swish and flick, the volume will go up. Which I think is pretty funny because one of my favorite comedians does a bit about how the remote is the magic wand of the 21st century. Swish and flick. Flick. Worked. Mm-hmm. I see. What's not to get?
Are you saying that we can't draw the other side?
I'm saying that sometimes you can't draw the other side.
So how does that work? Like, how do you know?
What do you mean, how does it work? Stand up, Max. Come here. Yeah, it's okay. Come here. Fine, you stay. Lauren, come here. You're a better... I know, you have to do it again. Over to Sonia's feet, up to me, my head, back to Sonia's feet. Makes a 90-degree triangle, yes? Okay? So that is the angle you have. I am the H. She is shorter than me, yes? Come here. If she was up to my height, would her feet hit the ground? No. So you couldn't have a triangle because she is shorter than the minimum height that you need to make a triangle, because the shortest distance between here and there is this straight line. She would be swinging. Like a bad guy in the Old West. Like a horse thief. Goes to that. I like having someone shorter than me in the front. It's very helpful. It's very rare that it happens because I am short. It does. Excuse me. Okay. So, what did we find? How many possible triangles for C? 2. Why?
Because the third triangle is 1 unit longer than the altitude, so
it could be on either side. Right? It's either going to be, I'm going to change my drawing. I will. I'm just changing the drawing first. So, as Dylan says, because the altitude is 132 and the other side is 133, I could be a little on either side of it. So I'm either making this triangle or I'm making this triangle with my altitude right there or my altitude right there. Does everybody understand? What if this was 233? Then how many triangles could I have? How many? Just one. And where would it have to be? Way out to the side, right? Because if I brought it back this way, it would be longer than my 233, and I couldn't make a triangle. Is everybody cool with sine law and all of its permutations? Yeah? Okay. Oh, look. Imagine that. Microsoft OneNote stopped working. So we're all good? Okay. Let us move on, cabbages, to the actual difficult one. The cosine law. Bum, bum, bum. Before anybody asks, this is where trig ends. There is no tan law. This is the pinnacle of trig. Relax, stay cool, everything is fine. You are going to do just fine. Now, have a look at that situation there. Look at the equation. And tell me if there's anything in that equation that I haven't shown you how to use it, but just have a look at that and tell me if there's anything in there that you can't explain. And when I say explain, I mean, is there anything in there that you don't recognize from something else? Anything? Where does A, B, and C come from? Pythagoras. They're the sides of the triangle. Cosine? It's adjacent over hypotenuse. So you've seen everything in here, right? It's kind of like you guys have all seen these, yeah? You know what these are for. They're pliers. They have a lot of different uses. But if I ask you to go down to my car and remove the fuse that controls the plug-in, could you do that? No, because you haven't seen the car, you don't know where the fuse box is and everything. But once you got there, when you saw the fuses, oh, they're a little thing that you pull out. Oh, reach, clip, pull. You could do it, right? Same thing here. You know what all these things are. We're just going to show you how to use it. Now, you do have to be a little tricky with the cosine law because how many sides are there in a triangle? 3. How many angles are there in a triangle? 3. Who decides what the angles are named? You do. So this will find me what? It will find me the length of side C, won't it? Provided I do what at the very end of it? What would I have to do at the end of all this work to find the length of side C? Pardon me, Carmen? Square root it. Because you see it gets me C squared, just like in Pythagoras. So as that stands, that will get me one side of the triangle, won't it? Everybody gets that? Provided I square root it. Now, what else will it allow me to find? Everything if I can do algebra. Do you understand what I'm saying? What if I wanted side A? What would that mean? If side C is A plus B minus 2AB cos C, yeah, I just move it around. Cool? So when it's C, I have cos C, AB cos C, right? So what would it be if it was A squared? It's A plus B when it's C, so this must be A. Oh, not A, duh. This must be B squared minus? Apparently. This is a formula, right, guys? So side C will be found by adding the other two sides, subtracting those same two sides, and multiplying by cos C, correct? All right? Okay. So what happens if I want A? Just don't overthink it. You are. You add the other two sides here, yes? So it would be B squared plus C squared. Minus what? 2BC cos A. Do you understand why? All of you want to do algebra here and move it around, don't you? Right? You all want to. That's why you're trying to fight me. Into minus, it had to be minus, because when I move it around, it's going to change sides. It has to be minus. I know. That's exactly what you said. The problem here is that assumes you know that angle. If that were the case, the only angle we would be allowed to use would be C, wouldn't it? Does everybody see? Okay. So what would find me B squared? A squared plus C squared minus 2AC cos B. All right. There you go. Now, those three options allow me to find what? Sides or angles? Sides. Do I sometimes need to find angles? Yes, I do. In which case, what needs to be by itself if I want to find an angle? The cos C needs to be by itself. So now we got to do algebra, don't we? So if I want cos C, it's got to be by itself, correct? So let's see if we can figure that out. Because we only need to figure it out once, right? Because the rest of them are the same, yeah? So this always messes kids up. You guys do right now, over here, try and get cos C by itself. It's just algebra. Get cos C by itself. There's one mistake that is often made. Okay, what should I do? Tavleen. Would you divide cos C on both sides? If you divided cos C on both sides, you would get rid of one cos C and you would have cos C over here, but it wouldn't be isolated, would it? It would still have a C squared there. Okay. Anybody else want to take a crack at it? Max.
I'm just guessing again, but like, would you subtract the a squared and b squared?
You would subtract a squared and b squared from both sides, wouldn't you? Or you would move them over there, right? So you would have c squared minus a squared minus b squared. And that would equal negative 2ab cos c. Now what? Add? Here's the mistake. You would divide what? Divide 2? You would divide negative 2. You need to get rid of negative 2a and b, and that's all times, yes? So you would divide this side by negative 2ab, and that would leave you with cos c. That's the mistake everyone makes. They either add because they see subtraction, or they forget to divide by a negative. Because that's negative 2, isn't it? Now, what does that mean all the rest of these are? The exact same thing, yes? This is a squared minus b minus c. This is b squared minus a minus c. Everybody cool? It's just algebra. Now let's apply these things. Oops. Sine law we already talked about. Sine law works when there's no 90 and we know one angle and its opposite side. We can make a pair. I'm going to draw it right there. As long as I know one of the pairs, I can do sine law. Right? Cosine law is all the rest of the time. Okay? If you don't have a pair, I shouldn't say that. If you can't get a pair, you have to use the cosine law. Everybody cool? And it just depends on which one you're doing. If you need an angle, you're doing this side. If you need a side, you're doing this side. Everybody good? Yeah? All right, let's practice. I got me a triangle here. AC, BC, and angle ACB. You guys have this, right? This is what's on your page? Okay. So how am I going to draw that? What am I locked into first? What do I have to draw? I have to draw a 20-degree angle, yeah? And I know that angle's ACB. So what's going right here on the corner? The C. Does it matter where the A and the B go? Not really, right? So if I make that A and I make that B, now, what's AC? 20. What's BC? 11. And this side is 20. So I need this little c, don't I? Everyone agree? Because once I have little c, I have my pair, right? Then I can sine law. Because who likes sine law better than cosine law? I hate cosine law. I want it to go away. I don't want to use it if I can avoid it. So once I have little c, I can kick cosine law to the curb, can't I? So I need little c, yes? So which version of the cosine law is that? I need little c, so that must be c squared equals a squared plus b squared minus 2ab cos c, correct? Okay, so what's a? What? 11. 11 squared plus what's b? 20 squared minus 2 times 11 times 20 times cos of what? Cos c, which was 20. That's a little bit hard to punch into your calculator, especially if you got a backwards calculator, yes? But you can do it. You guys try and figure that out. If you can't do it in one step, what are you going to do? You're going to go step by step, right? What's 11 squared? 121 plus 400 minus 440 cos 20. Right? Then what do you get for an answer? Pardon me?
107.
And what do you get, Dylan?
107.5.
107.5. Is Dylan done? Why not? Square root. That is c squared. Square root that. And how long is c? 10.4 will be fine. Once I have 10.4, what do I shift to? Oh, I shouldn't have said shift. What do I change to? Sine law, because I have my pair. 10.4 over sine 20, and then I work the rest through. Okay? I'm going to not do that and leave that for you guys as part of your homework, okay? You're going to finish this off. Because you already know how to do sine law, yes? I want to practice cosine law as much as I can. So put a little star by that because you got to finish it. Cool? Everybody good? Next triangle. Read it. Tell me what I have. I got what? I got 3 sides, right? I got RP, which is the short one. So there's RP. Then I got RQ, which is slightly longer. RQ, which is 8. And I got PQ, which is 10. Everyone agree? Does it matter how I draw it? No. As long as I have Q between the 10 and the 8, right? So I need Q. Wait a minute, Mr. Myers. That's kind of a dick move. all of our cosine laws are in ABC and you change letters. Does it matter? No. Because we know in the cosine law that cos C equals, which you wrote on the last page. Yeah, but we need the angle this time. So we got to move it all around, don't we? Cos Q equals what? Right, so it has to be 7 squared, yeah? Minus what? Does this order matter? No. 10 squared minus 8 squared over what? Negative 2. Times 10 times what? 10 and 8. So you're going to do all that math, and what are you going to find? You're going to find something very weird. What do you find? You're going to find that the answer is 0.7 blah, blah, blah. Is that the answer? No, of course not. Why? You have to shift coset. So Q equals 44 degrees. Priyanka. Your calculator, you've got to use your head. See, your calculator will only do what you tell it to. If you tell it wrong, you're going to get it wrong, right? If you actually work this out the way your grandparents had to work it out, this is negative 115 over, what's negative 2 times 10 is negative 20. Negative 20 times 8 is negative 160, right? Two negatives make a positive. Positive 707 or whatever it is. Right? Everybody cool? Do the letters matter? Nope. Okay. Now, as always, everybody says, oh, I'm never going to use this in real life. Math has no place in real life, except that it does. So here we have an actual problem that somebody in a real job needs to be able to figure out trig with. Wait a minute. Needs trig to be able to figure out. Strike that. Reverse it. Anyone? Willy Wonka? The good Willy Wonka, not the stupid Johnny Depp version? Willy Wonka. Chocolate Factory? Mike TV? Okay. This question, I took this question off a test from another province. And wait for it. It used to be on the test. And the kids looked at this number and they wrote 34,450 kilometers east. Apparently the plane was in space. The 344 is the flight number. It's only 50 kilometers away. We don't write numbers that way. Numbers go in groups of 3 to the left. Okay? The kids all had this drawing of the plane out here at 34,000 kilometers away. And they were like, Mr. Myers, I don't think this is very real life at all. It's flight number 344, and it's 50 kilometers away. Oh. So that's why this question has shifted from tests to notes. Because you can't have a plane that's 34,000 kilometers away. That's called the space shuttle. It was fun for me, though. All right. So, the flight is 50 kilometers east of the tower. Right? So where's east? What direction do we draw east? Straight to the right, correct? So I got a tower, and over here is flight 34,450. No, just flight 344. And that is how far? 50. Cool? Flight 712 is 25 kilometers from the tower. And the angle between them is 20. So do I know exactly where flight 712 is? I know how far it is away from me, right? It's 25 kilometers, right? Does it matter where I put it? Could flight 712 be up here, north of me? Yeah. And that would be 25, correct? And this would be 20. Agreed? But could flight 712 also be south of me? 25 and 20? Is that okay? Now here's the thing. Does it matter which triangle I draw? No, because the question asks what? How far 712 is from 344. Do you all understand? I could use the red triangle or I could use the blue triangle. It's not going to matter because these sides are the same, right? So I'm going to go ahead and erase the blue one because I bet everybody drew the red one, right? Did you draw the blue one?
I did, and then I erased it.
Then you erase. Shotzi, why? Why? It's the same thing. It's okay. So, is this a cosine law or a sine law? Cosine law. Why? No pair. Is it cosine law with the square root or is it cosine law with shift? Why is it square root? Because I'm not finding an angle, I'm finding a side. I didn't use A, B, and C. Does it matter? No. Can I name these corners anything I want? Sure I can. So the first cosine law I gave you said C squared was first, right? Do I have to make it that way? I can use any one I want. I can go A squared equals B squared plus C squared minus 2BC cos A. If I use that one, then where is A? Big A. That's the tower. If I use C, then this becomes C. If I use B, then this is B. Does it matter? No. So I'm going to go ahead and I'm going to call this guy A, and I'm going to run this, yeah? That makes this little a, correct? Then I just go ahead and I work it out. Boom. Now, can I save myself a step? If you're good with your calculator, can my first button be square root? If I have a forward calculator, could I go square root brackets and then put all this in brackets? I could. If I have a backwards calculator, I just got to punch all that in, and at the end I hit square root. If I want to. Could I also write it all out to make sure I did it right? Absolutely. You guys go ahead and try it. Go. I, of course, am writing it all out to show you guys. That's not right. Yeah, it is right. I thought so. How big is A? Yep. Everybody comfy with cosine law? All right. I'm just going to leave it there. And I'm going to shut up. And you guys are going to do... Now you don't... This isn't page 94 for you, is it? 89, right? We just did? Right. You guys are 5 behind me. So you're going to do 90. And then you're going to do... You're going to work in your blue book until page 93. And that's the end of trig. Okay, now listen up. Thursday, excuse me, is I lie. I'm the worst kind of liar. Thursday will be the cosine and sine law quiz. Cos and sine law quiz. Thursday. Friday will be trig review, which you'll finish over the weekend, and we will test on trig next week. Okay? Probably not on Monday, but we'll see. Okay? Tomorrow, we'll go over everything up to page 90, what did I say? 93? Tomorrow we'll mark that. Because you'll notice that 2 pages of it are assignment. Or 3 pages of it. I can't remember. Okay? So tomorrow, actually, let's do it this way, ladies and gentlemen. Tonight, Tonight, do page 90, and then 91, 92, and 93 will be your in-class assignment tomorrow, 4 marks. Okay? We're doing it tomorrow in class.
We don't do it.
You have to do page 90 for homework.
Just 90.
Just 90. Okay? You. Of course, if you want to, yeah. Yes, Chauncey. Sometime next week on everything, but you're going to quiz on Thursday. Yeah, we'll do it that way. Now, this, ladies and gentlemen, this might mean, depending on how well tomorrow goes, we might start the next unit tomorrow. Or I may give you your trig review ahead of time tomorrow and let you work on it. And then we mark it Friday. Something like that. That's actually probably what we'll do. Okay? Everybody cool? Just page 90 tonight. If you want to go ahead and get a head start on your assignment, go ahead and do that. But tonight is just page 90. Okay?
Did you collect the marks for the last video?
I don't remember. The next unit is roots and powers. And numbers. Ah. So we'll do that tomorrow. We'll start a review tomorrow. You'll quiz on Thursday. Finish and mark our review Friday. I'm going to change that on the board. Okay, that's where we are. I feel good about that. Do I have something for you guys? I thought I did. I do. I have a quiz to give back to you guys. It was out of 14. It was Trigonometry Quiz 2. Has anybody been on Check My Mark lately? Did I put this in? I did? Yeah? Okay. I'll give this back. And we have, well, only 3 minutes today, so not much time. But this, we can go over this tomorrow if you have a question about it. Now all the way back to the front. But you didn't. I gotta start marking these in seating order. I can go down one row. That's what I need to do. Nice job. Nice job. Everything's right side. Papers on the side of each other. Well, that one is. Wrong. Nope. They all equal each other, right? Son, John. Oh, sorry, John. You have to set up slightly. I'll show you. What? Yeah, it comes out of that, like, and I go for a little bit more. Have good days. Amanda, what did I assign you last night? Did I say to do the practice test? I did? Yeah. The whatever it's called in your book. Practice something. I did? And that's where I said to stop, yeah? Okay. But I left you with some... Like, I left you guys at... You had to do page 1991 too, yeah? Yeah, okay.
I don't know if we'll be able to make it at lunch anymore.
Okay.
I have to leave next block early for a doctor's. And I don't know if I'll be
So, okay, then I won't even print it. Just coming up, we'll sort it out. Don't worry. Hey, Emma.
Did you get to look over my quiz?
What?
Remember, like, I think
No, I didn't, because somebody pointed out something to me when they left and I got all flustered. I actually haven't fixed up your cumulative marks.
oh no, that's cumulative.
No, I know that, Jenny. But because I didn't fix up your cumulative marks, I got to checking. Somebody said, you didn't change my cumulative mark. And I said, sure I did. And then I went and checked my mark and I realized I didn't. So I got all, So I did not look over your quiz. No. Okay. Damn.
Good morning, everyone. Announcements for Tuesday, March 28th. Following students come down now to the Kilson hearing, of course, students to council, Jan Cruz, Penny Diol, Channy Dolliwa, 15 Sultan State, Leandro Cabran, Nikhil Kerr, Jim McGurk, Daniel Olmos, Donnie Roberts, Kirt Singh, Jeremy Sosnowski, Fraser Tessier, Keaton Gregor, Alyssa Ellis, Emily Gregory, Kenichi Kawazo, Emma Rasmus, Daichi Ko, Mackenzie Gay, and
Quiet, please.
Lunch day this week for an audition to Abby's Got Talent. So the auditions will run next week. Taking a Moorish Castle in Sintra, shopping for pork products in Lisbon, walking through a bullfighting arena in Seville on the beaches of Costa del Sol, visiting El Pampa in Grenada, and Los and Portugal in Barcelona. And then this is all of these could be yours during the spring break of March 2018. So for Abby Senior students, like